Hi everybody. In today's lesson we're going to learn about mass and volume and how those two things combine together to help us find density. Understanding density is our objective, but we must understand mass and volume first. Let's start with mass. Well, what is mass? Mass is the amount of matter in an object. So if you have, let's say, a big old block of steel, and it's a certain size, 2 feet by 3 feet by 4 feet, and you have an identical block of steel, another one. All right, let's take a look at this. We'll draw it. All right. They're both made out of, let's say, iron. Now we're ready to talk about density. Remember, with mass and volume, we were concerned with how much an object weighed or how much space an object occupied. We were dealing with objects. With density, we are not concerned with objects. We are concerned with the substance that the object is made out of. So, density. Density is a measure of how packed, how much matter is packed into a certain volume. If something is highly compressed, then it's got a high density. If something is really fluffy, like cotton candy, then it's got a low density. Foam rubber, styrofoam is real fluffy. Cotton balls, those things are low density. Lead, like lead fishing weights or bullets, or gold, the metal gold, those substances are very dense. The matter is packed together very tightly. So it's how much matter in a set volume of a what? Density is how much matter is packed into a set volume of a what? An object? No. Of a substance. Let's look at some examples. Suppose you had a cube 1 centimeter by 1 centimeter by 1 centimeter of pure gold. So this is gold. And suppose you had the same size cube of pure lead. And suppose you had the same size cube of iron. And suppose you had some water. In this case, it would be ice. They all have the same what? They all have the same volume, because they all take up the same amount of space. Would they all have the same mass? Well, gold, lead, iron, and water. No. The gold would weigh, the gold cube, 1 by 1 by 1 centimeter, would weigh 19 grams. The lead cube, do you think it would weigh more or would it weigh less? Well, yeah, it would, correct. It would weigh only 11.3 grams. What about the iron cube? Would it weigh more or less than the gold and the lead? The iron cube would only weigh 7.8 grams. And the water would weigh in at around 0.98 grams. So the mass is steadily dropping even though the volume stays the same. All right, so that's density. We can see gold is much more dense. It's got more atoms. And the gold atoms are heavier than the lead and the iron and the water atoms. And they're packed closer together. So there's more matter packed into the same volume for gold than for the others. We can calculate density by taking the mass of a sample, an object, okay, getting the volume of the very same exact sample or object, and do a division problem. Let's do an example. What's the mass of this gold cube here? The mass is 19 grams. What's the volume of that gold cube? Volume linked on width time height. 1 time 1 time 1. It's 1 cubic centimeter. Well, 19 divided by 1 is 19. So we say the density of that gold cube, the density of any gold object, not just this gold cube, will be 19 grams of mass per every cubic centimeter of volume. For the lead, a mass of 11.3 divided by a volume of 1. So 11.3 grams per cubic centimeter. Same method with the other two. Let's go back to the gold. No. Let's do lead. It's going to be easier for me to calculate. Let's say you have a piece of lead that's irregular and you drop it in a cylinder and it makes the water go up. It makes the water go up by 2 milliliters. It means that piece of lead has a volume of 2 milliliters, or 2 cubic centimeters. Well, if we put that on a scale and we weigh it, we discover it's got a mass of 22.6 grams. What's 22.6 divided by 2? 11.3. You're always going to come out with the same number. Density does not matter how much of the material you have, how much of the substance you have. The density will always be the same. The density of a drop of water is 0.99, can we just say 1 gram per cubic centimeter? The density of a drop of water is 1 gram of mass for every milliliter of water. What's the density of Lake Michigan? 1 gram per cubic centimeter. What's the density of a bathtub full of water? 1 gram per cubic centimeter. What's the density of a swimming pool full of water? Just the water. 1 gram per cubic centimeter. What's the density of a micro droplet, 1,000 times smaller than a drop of water? 1 gram per cubic centimeter. Because density is the same for any amount of the same substance. What's the density of a gold statue that's 6 feet tall? It's the same density as a pure gold earring, 19.3 grams per cubic centimeter. One last thing before we get off this topic, and that is determining volume. Because what two things do you have to determine before you can calculate density? You have to calculate mass, and you have to calculate volume. Mass would go to, what is the tools for mass? What tool do you use to calculate mass? Think about it. What's your answer? Hello? Okay, good. You use a scale, a balance, an electronic scale is fine. You get the weight. That's how you find the mass. To get volume, what are your two methods? If it's a rectangular solid, or what do they call it? Rectangular prism. It's a rectangular prism. You multiply what? Hello? Right. Length times width times height. To get the volume of an irregular object, you use what? Hello, say something. Very good. Water displacement. Thank you. I want to talk about water displacement. Water has a lot of unusual properties, and one of them is it is attracted to almost everything. So when the water is in the cylinder, it tries to climb up the sides of the cylinder, and it does. The more narrow the cylinder, the higher it can climb, because it doesn't have to pull that many other water molecules with it. So because the water molecules are climbing up the side of the cylinder, this zone right here is an extremely thin layer of water. It's called the meniscus. It is such a small quantity of water that we can ignore it in our measurements. So when you read the volume of water in the cylinder, because remember, you have to read the before volume, then you drop the object in, read the after volume, and then subtract to see what your volume is. When you do those readings, you read the bottom of the bottom. You read the lowest point. So whatever this is right here is what it's going to be. So many milliliters. You read the bottom line, and you read the lowest point of the bottom line. So we're going to do some practice next.